Welcome to the Explainer. So, you ever wonder what actually happens in that little moment right after you hit enter on a question for an AI? Well, today we're going to pull back the curtain on the very first, most crucial step of that whole process. It's a clever trick called tokenization, and it's basically how an AI starts to learn our language.
I mean, you talk to AI every single day, right? Maybe you don't even think about it anymore. But did you ever just stop and think, what is actually going on under the hood? How in the world does a machine, a thing made of silicon and code, even begin to understand something as wild and messy as human language?
Well, here's the secret. It's not that computers learn to think like us. No, the whole game is about us translating our language into a form that they can work with. And this is the absolute foundational step for any AI that needs to make sense of our words. And that gets us to the core problem, doesn't it? Computers don't speak English. They don't speak Japanese. They speak math. That's it. So for an AI to do anything at all with what we type, to analyze it, to respond to it, to write something new, it first has to turn all of our words into numbers. So this whole translation process really boils down to one simple but incredibly powerful idea. It's the key that unlocks everything, and it's called a token. So what is a token exactly? The best way to think about it is like a Lego brick, but for language. It's the smallest piece of text an AI works with. A token could be a whole word, maybe just a single character, or even just a common part of a word. The AI takes our sentences, breaks them down into these little bricks, and then gives each one a unique number.
Okay, and this slide, it captures the whole journey perfectly. You see at the top, we start with this messy human input, all kinds of weird punctuation and stuff. Then you can watch as it gets cleaned up, processed, and finally turned into that clean, neat, numbered sequence at the bottom. That is the language a machine can actually read.
The whole thing really happens in three pretty simple steps. First up, standardization. You just clean the text up, get rid of all the junk. Then, tokenization. That's where you break the clean text into those building blocks we talked about. And finally, indexing. You give every single one of those tokens a unique number, like a name tag from a giant dictionary. Now this is where it gets really interesting, because how you decide to break up that text, what you actually call a token, has a huge impact on how the AI works. So let's start with the most obvious way to do it, just treating every single word as one token. To see how these different methods really play out, we're going to use this one sentence as our little guinea pig. It's perfect, right? It's got some common words, it's got punctuation, it's even got that possessive apostrophe and earths. And with word-level tokenization, the result is pretty much exactly what you'd expect. The sentence gets chopped up everywhere there's a space. Each word, and notice this includes the punctuation attached to it, like moon with a comma, becomes its own unique token.
Now the great thing about this method is that it's just simple. It makes sense. But, and this is a huge but, it has a massive weakness. The AI has to have a dictionary with every single word it could possibly see. So what happens if it sees a brand new word, or a typo, or some new slang? It just breaks. These are called out-of-vocabulary words, and they can totally throw the AI off.
So to get around that huge vocabulary problem, there's another method that goes to the complete opposite extreme. What if, instead of using whole words, we broke the text down into the absolute smallest parts, individual letters? And when we apply this to our sentence, whoa, it gets completely atomized. Every single letter, every space, every comma, every apostrophe becomes its own separate token. You end up with this incredibly long string of tokens. So the upside is obvious, right? The vocabulary is tiny, just the alphabet and some symbols. You'll never get an out-of-vocabulary error. But the trade-off is huge. The AI loses the meaning that's baked into a word. It has to learn what a moon is just by seeing the letters M-O-O-N next to each other over and over again. And that is a much, much harder job. Okay, so we've got one method that's way too strict and another that's way too broken down. And that brings us to the smart compromise, subword tokenization. And this, right here, is the method that powers pretty much all of the advanced AIs you use every day. Subword tokenization is just a brilliant hybrid. It really does give you the best of both worlds. Just look at our sentence here. Common words like the and moon get to stay as single tokens, but a more complex word like earths gets broken down into its meaningful parts. Earth, the apostrophe, and S. This is so powerful because the AI can understand both the core word and the grammar attached to it. I mean, this really is the sweet spot.
It keeps the vocabulary size from getting out of control, but it's also incredibly good at handling new words. So if it sees a word like tokenization for the first time, it could just break it down into familiar pieces like token and ization and still figure out what it probably means. And that flexibility also makes it amazing for working with lots of different languages.
Okay, so we've gone through the how, but let's talk about the why. Why should you actually care how a computer breaks down a sentence? Because this little technical detail has some seriously big real-world consequences.
This table lays out the whole trade-off perfectly. Look, for our one sentence, word tokenization gives us just 18 tokens, but it means this enormous dictionary of over 170,000 words. On the complete other end, character tokenization creates over 100 tokens from a tiny vocabulary. And then right there in the middle, you've got the sweet spot, subword tokenization.
And this bar chart just makes the difference impossible to ignore. Look at how much the number of tokens changes for the exact same sentence. And this is so important because every single token costs computing power. More tokens means more processing, which means more time, and you guessed it, more money to run the AI. It's literally the reason why a lot of AI services actually charge you per token.
So look, this is not just some academic thing. The choice of tokenization directly changes how smart, how fast, and how expensive an AI is. It's what determines if it can handle new slang, understand your typos, or even speak another language. It's the engine under the hood. And all of this leads to a really fascinating final question. Tokenization is the foundation of how AI understands us today. But what if we could move past it entirely? Researchers are already looking into what they call token-free models. And it makes you wonder, if we change the most basic building blocks of how AI learns, could we be on the verge of a completely new kind of artificial intelligence?